This lesson is about interquartile range and outliers on box plots. The interquartile range represents the middle 50% of a data set. So on the box plot, it's the data that's represented by the box. The formula for the interquartile range is interquartile range equals quartile 3 minus quartile 1. So it's the differences between the upper value and the lower value on the box. Outliers are unusual data values. Outliers can occur by chance, because of error in measurement during data entry, or from errors in sampling. Outliers do not always occur because of an error, though. Sometimes extreme observations are common within a population. I used to personally work at the USDA doing agricultural research. During one particular survey, we had an extreme outlier. We had to call the person who had completed the survey and ask about it. And it was a valid data value. It just was a very unique situation. So we had to include the outlier in our research, though we did make a comment on it. Now let's take a look at how you determine if something is an outlier. First, we need to know how to calculate a lower fence and an upper fence. A lower fence is the lowest value that would be considered a normal value, and anything below this lower fence is going to be considered an outlier. It is calculated as taking quartile 1 minus 1.5 multiplied with the interquartile range. What this aspect is doing of 1.5 times the interquartile range is it's taking the interquartile range and magnifying it by another 50%. So it's 150% of the interquartile range, and we subtract it from the lower quartile. Then very similarly for the upper fence, we take quartile 3 and add on 150% of the interquartile range. Anything above the upper fence is considered an outlier. Let's take an example of a set of data. The set of data represents the hemoglobin levels for 20 randomly selected cats. Using technology, a 5-number summary is ran and found. The 5-number summary is 5.7, 9.15, 9.95, 11.10, and 13.4. Now to find the interquartile range, I find quartile 1 and quartile 3. Subtract those values to find out it's a 1.95. Now I find the lower fence. For the lower fence, I take quartile 1. I subtract from it 150% of the interquartile range. I came up with 6.23. Similarly, for the upper fence, I take quartile 3, add 150% of the interquartile range to get 14.03. That means any value lower than our lower fence and any value above our upper fence is an outlier. Looking at our data values, 5.7 is lower than our lower fence, so it is considered an outlier. Looking at the upper fence, I have 14.03. There's no data value greater than 14.03. There's no outlier on the upper end. I took this data and put it into StatCrunch. It's arranged in order presently. To graph it, I chose box plot. I need to select my variable. And then I'm going to choose to have it identify outliers. I'll draw this box horizontally, and I'll label the x-axis accordingly. Now when I look at this box plot, I can see that there's a blue dot over here letting me know that this is an outlier. If I hover over it, it will tell me that it's from row 1 and that it was a data value of 5.7. Now the lower limit of our box plot is 7.7. All the rest of it remains the same. Quartile 1 is still 9.15. I can go back and I could modify this to see what it would look like without the outlier. We can see that there's this long whisker over on the left. It may be valid, but it may not be, and that's why we need to know what the interquartile range is and then what the lower fence is. Fortunately, with technology, it'll do a great deal of our work for us and identify that we have an outlier.